Welcome everyone. It is 3 p.m. and it's time for a server room show. This is episode 42. And I think on the video I don't have audio. I don't know. Let me see. That's my line in. I should have audio there. Let's remove these things quickly. Maybe now? No, I don't hear anything on that one. Okay, maybe there is no audio on the video feed today. I will fix it afterwards. So today I would like to talk about, because the last episode we talked about monitoring solutions, and something which goes hand in hand with monitoring solutions is this they call sometimes dashboards, but officially they are called analytics and interactive visualization solution tools or software, and they go very nicely hand in hand with most of the monitoring software, because these analytics tools, these visualization tools, they can receive the input from monitoring software or monitoring solutions like OpenNMS, for example, and display the metrics and the data in a visually much more pleasing way, because monitoring software are not really good in this sense. And one of the dilemma I came across was that it was while I was preparing this article for this episode, is that I quoted myself that most monitoring softwares are not so great in presenting visually these metrics and data what they acquire, but some analytics and visualization solution tools make a near perfect monitoring solution, which is pretty strange. And the dilemma it causes, what I'm trying to say with this, that while monitoring software like the ones we discussed in the previous episodes, OpenNMS or Nagios or Zabbix, they are not very ace in visualizing these acquired metrics and data in the most beautiful form possible, which makes us couple a monitoring tool most of the time like OpenNMS with Grafana, like I mentioned. Grafana is what I'm going to talk, one of the things I'm going to talk about today. So while most of the time we combine a monitoring tool, a monitoring software with a kind of data visualization solution to achieve our desired outcome, surprisingly enough, some of these analytics and visualization layers or tools are getting better and better to include functions from monitoring softwares, such as alarms. And therefore I had a bit of a hard time while I was preparing this article to try to draw a line with some of these tools and many others also, which I nearly included in this list of today. I had a hard time to figure out where a data visualization and analytics software ends and a monitoring software begins, because this line seems fuzzier each time I look at it. And for the moment, monitoring softwares have more on the monitoring and handling alarms and on the spectrum, and less on the presentation and visualization of the acquired metrics. But analytics and visualization tools are becoming more and more a hybrid, so to say, to try to exist in both worlds, maybe to try to keep you in that one single pane of glass. One of the main attraction in this bunch is one of the well-known ones called Grafana, which is around since a good couple of years. Right out of the box, for the ones who look at my screen, right out of the box is not as many of these tools is not the most user-friendly or the most easy to start with. However, you can set it up pretty much quite easily. Grafana is a multi-platform open source analytics and interactive visualization web application. It provides charts, graphs, and alerts for the web when connected to supported data sources. It is expandable through a plugin system, and users can create complex monitoring dashboards using interactive query builders. As a visualization tool, Grafana is a popular component in monitoring stacks, often used in combination with time series databases such as InfluxDB, Prometheus, and Graphite. Monitoring platforms such as Sensu, iSinger, Zabbix, NetData, PRTG, some security information and event management systems such as Elasticsearch and Splunk, amongst other data sources. We have to mention what is a time series database. A time series database is a software system that is optimized for storing and serving time series through associated pairs of times and values. In some fields, time series may be called profiles, curves, traces, or trends. Several early time series databases are associated with industrial applications which could efficiently store measured values from sensory equipment, also referred to as data historians, but now are used in support of a much wide range of applications. In many cases, the repositories of time series data will utilize compression algorithms to manage the data efficiently. Although it's possible to store time series data in many different database types, the design of these systems with time as a key index is distinctly different from relational databases, which reduce discrete relationships through referential models. A time series database typically separates the set of fixed discrete characteristics from its dynamic continuous values into sets of points or tags. An example is the storage of CPU utilization for performance monitoring. The fixed characteristics would include the name CPU utilization. The units of measure would be a percentage, and a range would be from 0 to 1. And the dynamic values would store the utilization percentage and the timestamp. The separation is intended to efficiently store and index data for application purposes, which can search through the set of points differently than the time indexed values. The databases vary significantly in their features, but most will enable features to create, read, update, and delete the time value pairs as well as the points to which they are associated. Additional features for calculations, interpolation, filtering, and analysis are commonly found but are not commonly equivalent. In the below example I will show on my screen in a second, I used Grafana together with InfluxDB and Telegraph, these three key components together to very simply just monitor this localhost for basic metrics as seen on also on the screenshot, but I will show right now the real data. Many times this is also known as the TIG stack, Telegram, InfluxDB, and Grafana. We did mention Grafana just before we talked about time series databases. Grafana is an open source data visualization and monitoring suite. It offers support for Graphite, Elasticsearch, Prometheus, InfluxDB, and many more databases. The tool provides a beautiful dashboard and metrics analytics with the ability to manage and create your own dashboard for your apps or infrastructure performance monitoring. The part Telegraph is an agent for collecting, processing, aggregating, and writing metrics. It supports various output plugins such as InfluxDB, Graphite, Kafka, OpenTSDB, and so on. And the last but not least, InfluxDB is an open source time series database written in the Go language. optimized for fast, high availability storage and used as a data store for any use case involving large amounts of timestamped data, including DevOps monitoring, log data, application metrics, IoT, sensor data, and real-time analytics. This on my screen is the screenshot, but I can show you the live thing running right now on this computer I'm using to well, actually I'm not using this one for the podcast. I would use this one for sharing the audio and video stream to twitch.tv, but it seems today it's decided not to transfer my audio, and I would love to know why is it doing that. Now it came back for a second. Okay. So as you see, with Telegraph and InfluxDB and Grafana, it's very easy to set up something like this, which monitors your simple data regarding your host, like disk I/O and network traffic and processes, CPU usage and load, memory usage and uptime. I left the links in the show notes how to set this up. I had to go step by step and install Grafana, then installed InfluxDB, create the database required for Telegraph and the user and username and password for the accessing the database, and then I had to use a simple template to configure Telegraph, actually what to send to InfluxDB into this database created and called monitoring, where I store this timestamped data you see right now being visualized by Grafana. It sounds more complicated than it is, and I'm not gonna say that I set this up in 5 minutes, where probably I could have if I paid more attention to the instructions given. I definitely suffered more. I think I eventually spent at least an hour where I committed various issues and failed at various steps, and the moment I started to follow the instructions as they were written out letter by letter, the whole thing with Grafana and Telegraph and InfluxDB was up and running in really a matter of like 10 or 15 minutes. I didn't want to use a Docker instance just to spin it up, because most of the time what happens that if I use a Docker instance, then actually I don't really do the heavy lifting. I find myself not needing to know what goes underneath or the pieces, how they work together or how they build together to do what they need to do. And that's why I said I don't wanna use a Docker instance. I want to set this pretty simple thing up on my own with each piece on my local machine and see how it goes. And I definitely learned from the experience. And what I can tell you that if you want to dive deeper into this analytics and these time sharing databases and all these bits and pieces you can use to practically shift through data or metrics, however you wanna call it, it's a definitely another rabbit hole you can go down, and it's a very big and broad topic. Definitely much more than anyone can tell you about in half an hour or even more. There is great documentation on most of these tools, but you can also find some good videos on YouTube. Sometimes not everything so self-explanatory. Definitely when you try to figure out these tools, what does what, they not always doing a great job on their own website to explain what exactly it is doing. But then the more you Google and read around, the more you figure out. So that's what you saw, was just a very simple example of using Grafana with a time sharing database and Telegraph agent to collect and process and write those metrics into the database, and then Grafana is the single pane of glass which shows you what actually is being captured, or what actually is going on. The next known example of this visualization analytic tools would be Kibana, which in many ways similar to Grafana, but I probably forgot to mention, but Grafana, you can see on my screen actually, one of the main advantage of Grafana that it can use a lot of different data sources, time series databases. It supports a good couple of them, like Prometheus, Graphite, or InfluxDB. You can use logging and document databases like Grafana's Loki is one of their own, or probably Elasticsearch. I will talk about it in just a couple of minutes. And you can use, of course, SQL Server or Postgres or MySQL. You can get data from cloud like Azure Monitoring or Google Cloud Monitoring or CloudWatch, and it supports other enterprise plugins like Splunk or ServiceNow, even the ticketing, mostly known as a ticketing tool we used in other places. However, Kibana, which is similar in many ways to Grafana, one of the main key difference that Kibana can only support as a data source Elasticsearch, and this can be a real deal breaker for many if they wish to work with other data sources than Elasticsearch. However, Kibana is, as far as I googled around, Kibana can deal with text, while Grafana not really. If you Google, I left a video in the show notes. One of the guys explanatory video between Grafana versus Kibana, and he explains this part much better than I can. That what does it mean that Kibana can deal with text when Grafana cannot, as a form of a metric? And it's a quite short video, but it's very nicely explained, and he has even more videos of how to set this whole thing up. Long story short, in his video example, he shows that with Grafana, for example, he cannot visualize, for example, the tags or the keywords using a honeypot as an example. He cannot show the keywords attackers are trying to use, trying to get access to his honeypot. This data he cannot visualize with Grafana. As he explains, Grafana cannot work with text in this sense, or text fields in this sense, while Kibana can leverage from this, and you can see in his video it's visually looks very, very pleasing. So that's one of the main difference between Grafana and Kibana. Kibana can only work with Elasticsearch. The real term is that Grafana does not allow full text data querying, while Kibana does, as it runs on top of Elasticsearch, and therefore it's used primarily for analyzing log messages. And if you watch that video I mentioned in the show notes, you will you will immediately understand what I meant, or actually you will have a better understanding for sure. Kibana is an open source data visualization dashboard for Elasticsearch, as I mentioned. It provides visualization capabilities on top of the content indexed on Elasticsearch cluster. Users can create bar, line, and scatter plots or pie charts and maps on top of large volumes of data. Kibana also provides a presentation tool referred to as Canvas that allows users to create slide decks that pull live data directly from Elasticsearch. What is Elasticsearch, now that we mentioned it many times? Elasticsearch is a search engine based on the Lucene library, which is from the Apache Foundation software. It provides it's free and open source. It provides a distributed multi-tenant capable full-text search engine with an HTTP web interface and schema-free JSON documents. Elasticsearch is developed in Java, following an open core business model. Parts of the software are licensed under various open source licenses, mostly the Apache license, while other parts fall under the proprietary source available Elastic license. Shay Bannon, who is the creator of the precursor to Elasticsearch, which was called Compass in 2004, while he was thinking about the third version of Compass, he realized that it would be necessary to rewrite big parts of Compass to create a scalable search solution. So he ended up and created a solution built from the ground up to be distributed and use the common interface JSON over HTTP, suitable for programming languages other than Java as well. Shay Bannon released the first version of Elasticsearch in February 2010. Features of Elasticsearch are that Elasticsearch can be used to search all kinds of documents. It provides scalable search, has near real-time search, and supports multi-tenancy. Elasticsearch is distributed, which means that indices can be divided into shards, and each shard can have 0 or more replicas. Each node hosts one or more shards and acts as a coordinator to delegate operations to the correct shards. Rebalancing and routing are done automatically. Related data is often stored in the same index, which consists of one or more primary shards and 0 or more replica shards. Once an index has been created, the number of primary shards cannot be changed. Elasticsearch is developed alongside a data collection and log passing engine called Logstash, an analytics and visualization platform called Kibana, which we just talked about briefly, and Beats, a collection of lightweight data shippers. The four products are designed for use as an integrated solution, referred to as the Elastic Stack. Formerly, they called this the ELK stack. As I said, Elasticsearch uses Lucene from Apache Software Foundation, and it tries to make all its features available through the JSON and Java API. It supports faceting and percolating, which can be useful for notifying if new documents match for registered queries. Another feature is called Gateway and handles the long-term persistence of the index. For example, an index can be recovered from the gateway in the event of a server crash. Elasticsearch supports real-time GET requests, which makes it suitable as a NoSQL data store, but it lacks distributed transactions. On the 20th of May 2019, Elastic made the core security features of the Elastic Stack available free of charge, including TLS for encrypted communications, file and native realm for creating and managing users, and role-based access control for controlling user access to cluster APIs and indexes. The corresponding source code is available under the Elastic license, source available license. And in addition, Elasticsearch now offers security information and event management and machine learning also as part of its offered services. The combination of Elasticsearch, Logstash and Kibana, referred to as the Elastic Stack, is available as a product or service. Logstash provides an input stream to Elasticsearch for storage and search, and Kibana accesses this data for visualization, such as the dashboards. Elastic also provides Beats package, which can be configured to provide pre-made Kibana visualization and dashboards about various database and application technologies. Grafana Loki I did mention as one of the source. If you look at the screen under logging and document databases for Grafana, Loki is definitely an alternative to Elasticsearch. It's a product of Grafana. I mentioned Graphite here in my notes, but this is, you see, one of the examples that these tools don't make a very good explanation on their own website what each of them do, or most of them don't not doing a good explanation. Because if you look at my screen, you can see that under data sources in Grafana, Graphite is mentioned as a open source time series databases, similar to Prometheus and InfluxDB. However, when I was preparing the show notes, and actually I did install Graphite here, you can see on my screen, just as I have Kibana with some sample logs data in running on my host right now here, together with Grafana, like we discussed. Graphite didn't do a very good job explaining what it does, because what it says of itself is it's a tool that monitors and graphs numeric time series data, such as like a performance of a computer system. And it did say that it collects, stores, and displays time series data in real time, but as you see, it's mainly a time series database, just like InfluxDB. So most probably I will cut this part out from the show notes, because it didn't it doesn't belong here in the end. So the two main one therefore is gonna be Grafana and Kibana I mentioned today in this episode. In the very beginning, when I started to prepare this article, as I said in the beginning, there is a very narrow line in between that, where one kind of software ends and where another one starts, like between monitoring softwares and this data visualization or dashboarding solutions like Grafana, because you see now Grafana started to in the new version 7, which just came out a while ago. Now alerts will be handled in Grafana as well. More and more these applications are becoming a hybrid, as I said, that it will be hard to distinguish between is it a monitoring infrastructure monitoring software, is it just a visualization platform, and therefore as I mentioned with Grafana, you combine it as popularly people do, combining it with monitoring solution like OpenNMS, and use Grafana to visualize on those data and metrics. But this line is getting more fuzzy as you're looking at it, and you dive into more and more into these tools, and like you see, sometimes it's even hard to find a simple explanation that which piece does what, and you have to check in a couple of places to figure out, and I mean, eventually that's how we learn, and even myself, I already know more than I knew 5 days ago. Thank you very much, and see you next Saturday.